Hey guys, we're going to be talking about energy usage again this week. So the physics principles that we're going to be going over are electric force. The only other natural force is gravity, so that's kind of cool, I guess. And for an electric force is only formed when there's a difference in the charges, and it depends on how far apart they are. Then an electric current is when there's a force traveling somewhere, so we can use Ohm's law to find current, voltage, resistance, all that kind of stuff. And if in a circuit we have our resistors in order, the voltage is going to be adding up and the resistance is going to be adding up while current is constant. In a parallel series, so if it can go through each one differently, the difference in voltage is going to be the same again across every resistor, while the current total is going to be in adding up of all the different currents, and resistance is actually going to be the inverse of resistance equals the inverse of R1 plus the inverse of R2 plus the inverse of R3. So that's kind of cool that it works out that way. Then electric power is measured in watts, joules per second, and it's given by power equals current times voltage. Energy is power times time. Then using Ohm's law, we can rearrange these equations. So power equals current squared times resistance, or power equals voltage squared divided by resistance. So if we jump into my house, the appliances, the ever wonderful stove, the fridge, and then the entertainment system for my apartment, and then of course light bulbs. Lots of light bulbs. I think we have 20 total light bulbs in my house. So I broke it down. Oh yeah, appliances not shown. Water heaters, furnaces, those are down in the basement. Kind of a scary place. So for calculations, to find seconds per month, which is something we're going to need for a later calculation, I took an average of 30 days a month times however many hours a day we use the appliance times the 3600 seconds per hour. Then the energy in joules per month is seconds per month times wattage, seconds the appliance is used. And then total wattage of everything that we used is going to be adding up all of the wattages of the light bulbs, the stove, the cell phone chargers, everything that's being used. And we found the total to be 27,115 watts. So I have it broken down a little bit here by appliance, the usage in hours per day, and then usage in seconds per month, that's the equation we needed that number for earlier. Then the wattage of each of those. The furnace actually kind of surprised me at 18,000 watts. Like, wow, okay. And then for energy used, I used the equation on the previous slide to find the energy used. To find the total energy, we're going to add up all of those here in a minute. Notice that laptops times 3, so we're not all three using our laptops for 15 hours a day or our cell phone chargers for 18 hours a day. I just did a sum of all of them since they operate on basically the same level. So the power used, the maximum current to my apartment complex is 400 amps and the voltage coming in is 440. I had to go talk to my realtor about that one. So maximum power is going to be power equals current times voltage. So 400 times 440 is 176,000 watts. So we found the total wattage before to be that 27,115. So if you take what we use divided by the total possible, it comes out to 15.4%. So we're using about 15% of what the apartment complex can use at maximum power capacity, which should be about right since there's 6 apartments in my complex. So the sum of the energy we did before, so it comes out to 6.86 times 10 to the 9th joules a month, which is a lot of energy. So to reduce my energy by 30%, I would then be using 4.8 times 10 to the ninth joules a month. So joules a month we want to find joules per second because that's equal to watts. So we go through the process. So 6.86 times 10 to the ninth divided by 2.6 e times 10 to the sixth. Sorry, I use e's a lot for shorthand. So that comes out to 2,569.23 watt hours, which is 2.57 kilowatt hours. Then we do the same for the reduced energy, so 4.8 times 10 to the ninth divided by that 2.6 times 10 to the sixth equals 1,846.15 watt hours, which is 1.85 kilowatt hours. So then the cost of it all, we break it down. Since we have kilowatt hours, we're paying about 12 cents a kilowatt hour. So for my regular is that 2.57 kilowatt hours times 12. It's costing me about 31 cents a month. And then saving, it's costing about 22 cents a month. So we kind of thought about it, and the easiest way to save all of the energy was to turn off the TV and PlayStation, because we always turn on shows and then they just keep on going and everybody leaves and is going and doing other things and they're just sitting there playing. So we could definitely cut down a lot. We probably watch only about an hour a day total. So that would save 4.6 times 10 to the 8th joules per month, which is as much as we wanted to reduce just about. And then if we just wanted to change our light bulbs, use the microwave less, turn the heat down in the house, take shorter showers, like the things we always hear about. So glad we went over the power that is in our homes. Thank you guys.